Right, do you know that we can use some simple measuring tools to draw, say, parallel lines, perpendicular lines, and equilateral triangle? I would like to illustrate how we can make use of like set squares. This is a pair of set squares, rulers, and sometimes we may need compass, okay, to draw, say, parallel lines. First, we start with parallel lines. Now, first we draw a straight line here, okay, and then I want to have the other line which is parallel to this straight line, and then we can place, say, the set square in this way, and then we put the ruler, okay, such that it stick to the straight lines that we just have drawn. And then we make sure your set square is pushed tightly on the paper. Don't let it move. Don't let it move. Okay, and then we push. We can just push our ruler upwards like that, and then if we think that this is the position that we want to have the line, we stop here, and then draw the other line. Then in this case we have a pair of parallel lines. Now in case we would like to draw, say, perpendicular line and we don't have the protractor with us, it means we cannot measure the angles, and then in this case we just illustrate with this line. I want to, say, draw a line, okay, passing through, okay, this straight line. Okay, maybe I give it a name. Okay, this line segment AB. Okay, and then we can, say, make use of our compass. For example, I mark one point here, and then the other point here, and we can make use of our compass. Okay, for example, we have this length, any length will be fine. And then we just place the pin on point A like that, and then we draw something like that. Okay, we are not drawing circle, that's why just draw a little arc is fine. And then we just do the same by putting the pin on point B, and then we do the same. Okay. And oh, I forgot to do one more thing. We should do it the same below the line. Okay, I place it back below the line. And then in this case we find that there are two, okay, points of intersection here. Okay, the points of intersection of two arcs. Okay. After we have found these two intersections, we use a ruler to join these two points together. Okay, and then in this case, this one should be a right triangle, and you can verify if you have a protractor. Okay, you can put it. Okay, maybe I show it here like that. Then you can see that, okay, like that. These two lines are perpendicular. And for using the similar techniques by using the compass, we can also draw some equilateral triangles. Okay, let me illustrate how we can do it. Let's see. If I want to have an equilateral triangle with say length, okay, this length, okay, I mark this point A, and then I mark this point B, okay, and then I just have a compass, okay, and then if I put the pin here, and then I put my pencil here, Now then in this case, actually the compass is used to copy. We can say that we copy the length, okay, the length of the line segment, because when we put our compass here like that, okay, the pin is here, the pencil tip is here, therefore it means the length between these two, okay, these two tips actually is the length of the AB. And then in this case, for an equilateral triangle, I have 3 sides equal. That's why it means from point A, I measure from point A to the third vertex, somewhere here, should be the same length as segment AB, right? But I don't know where the point is because we don't have enough information to define the third vertex, okay? But in this case, it means if I measure from point A to this part on the arc, measure point A from all this point on the arc, it's just the same. It's just the same because it's just like we are drawing a circle, but we haven't finished drawing the whole circle. That's why it seems that A is the center and this length is the radius. That's why the length from the arc to point A is just the same length. And then we do the same at point B. In this case, it's just like we taking point B as the center, and then this is the radius, and then I draw the circle, but I just draw a part of it. Now then in this case, we have points of intersections, okay? This point is on both arcs, okay? That's why it means the length from this point, okay, I name it point C, okay? This point from point C to point A, or the length from point C to point B, both lengths are the same. And therefore, if I join the points together, I form a triangle, and then this one is an equilateral triangle, okay? It means I copy the length here. You can double check. Okay, AB and BC are having the same length, and then AB and AC are having the same length. Okay, that's why 3 sides are equal, and then I got equilateral triangle. Okay, right. Maybe you can try to use these instruments, okay, these two, to create some more nice pictures. Bye.